Hello, so let us look at number 3 from the year 2010 questions. Alright, now, so I'm going to give you a little bit of time for you to look at the question, and we're about to answer that together. Alright, so there are 700 people in line for amusement park ride, okay? That seems to be the initial condition. Once it begins operation, the ride accepts the passengers until park closes at 8 hours later. Okay, now, while there's a line, people move on to the ride at the rate of 800 people per hour. That's another rate that's given. The graph above shows the rate once again at which the people arrived at the ride throughout the day. Alright, now then let's try to look into part A first. How many people arrive at the ride from 0 through 3? We're talking about, this is integration from 0 through 3 for r of t dt, where r of t is this graph. Then all we have to do is figure out the area under this curve. Now, then there are many ways for us to do it. One way for us to calculate this one is finding the area under this portion, and then maybe I'll just convert this one into this way. How about that? This is 3 times 800, so this is 2400. Right? This one is 1 hour times 400, but it's a triangle. So therefore, 1 times 4 divided by 2 is 200. And here, if I were to cut, this one will be 200 is the height, or 200 is the base. Then it becomes 400. And here, once again, 2 is the base, and then 200 divided by 2 becomes 200 here. So therefore, when you add up everything, then what we end up getting is this: 2400 plus 400 plus 200 and additional 200 becomes, I believe, 3200. Now, number B. Is the number of people waiting in the line to get to the ride increasing or decreasing between t equals 2 to 3? Now, then I'm going to erase this portion just a little bit so that we can figure out part B. So between 2 and 3, then we're talking about this area. Make it a bit bigger. Right over here, between those two. Now, then in this case, one thing that which you get to realize is this: since within that 1 hour, how many people will be arriving? In fact, obviously it's going to be more than 800 people. So up to here will be 800, and here becomes 200 as we calculated earlier. Now, since 1,000 people arrive while only 800 people will move on to the right, the line will increase. Alright, simple as that. Let's look at part C. At what time t is the line for the ride longest? In fact, how many people are in the line at the time? Justify your answer. So here, let's try to calculate part C on the bottom. One thing which you have to calculate is this. How do you know what affects the length of the line? So let me call it L of t. In fact, L of t will be calculated by two things. Initially, we already had 700 people. Now, plus 0 through particular time, which is t, for the function r. I'm just changing the variable r of s at particular time. This is the amount of people who will be coming in with the initial amount of people, which is 700. But since only 800 people will be removed per hour, what's going to be happening is this. L prime of t simply becomes r of t minus 800. Now, r of t is already given, so 800, if I were to just make a mark for 800, then you will realize that before, when t is equal to 3, you will see that we have most number of people. But from 3 and up, we will have more people riding the ride than they're coming in. So therefore, this is almost like having the first derivative, where this is the x-axis. You can imagine it in that way also, where positive to negative reach the maximum. Same idea. Now, then, in this case, we get to realize that that's when t is equal to 3, maximum line will be formed. Now, but the next we have to figure out is how many people are in the line at the time. So that's rather simple, because we just have to calculate 0 through 3. We already calculated, which was 3200. So then when we plug it into here, L of 3 is equal to 700. Plus this we calculated already, which was 3200. And this one is minus 800 times 3, which is 2400. Once you calculate this one, you will realize that we will have 1500 left. People will be waiting for the ride. Now, part D. Write but do not solve an equation of solving integral expression of r whose solution gives the earliest time t, which there is no longer of a line formed. So in fact, we already calculated that expression earlier, so all we have to do is 0 equals 700 plus 0 through t r of s ds minus 800t. That's it. All right, I'll see you guys later. Bye-bye.